Good morning. It's great to see everybody here. Hi, I'm Lukas Bergstrom, Product Manager for Android Architecture Components. And before I get started, I'm curious, how many of you were here last year when we announced Architecture Components for the first time? Awesome. OK, this is a much bigger venue, so that's actually a decent percentage. When we did launch Architecture Components last year, we were doing something sort of different for us. For the first time, we were offering explicit guidance in how to architect your app and giving you components, letting you do that. And frankly, for us, it was a little bit of a journey into the unknown. So 12 months in, let's check in on how we're doing. So we've shipped 26 releases since May of last year. So we've been constantly iterating and improving on the core set of architecture components. In the sign of any healthy open source project, we have a very active issue tracker. I'd like to thank everybody that's taken time to file a feature request or even a bug. And we've closed a lot of those. We launched a major new library, paging, which is now stable, and we'll talk a little bit more about today. And I'm pleased to say that based on our survey data, over half of you are using or planning to use architecture components. And this survey was done only a few months after we went stable, so this data is pretty out of date by now. But I'm pretty proud of the fact that only a few months after launching to stable, over half of the Android developers we talked to were planning to use this stuff. But more importantly than any of this, you've told us that architecture components actually make it easier for you to build robust apps. That having a clear path on how to architect your app and components that help you realize that has actually made a difference in the real world in how you build your apps. And we've heard that not just once, but we've heard that over and over from a lot of developers that have taken time to speak to us. So architecture components has grown, and we're going to continue to invest here. This is foundational, we think, for Android apps going forward. But not just are we investing in architecture components, but this year with Jetpack, we're going to take that same approach that we took with architecture components, a blank sheet of paper approach to how Android developer experience should be and how we can improve things for you. And Jetpack is going to take that and apply that to the rest of the developer API service that we offer. So now I'm going to turn it over to Yeet to talk about what's new in architecture components.
Thanks, Lukas. Thank you. So we will talk about what we have been doing in this last 1 year. We'll look at the existing libraries, talk about the improvements, and also look at the new shiny stuff, paging, navigation, and WorkManager. Let's start with Lifecycles. So we have shipped Lifecycles in the last I/O. But to better understand why we have created this component, let's go to 2 years before. In 2016, we did a bunch of developer surveys and asked developers, what is the hardest part of Android development? And by far in the list, big surprise, was lifecycle management. We're wondering, what can be hard about a phone rotating or user switching applications? This happens all the time on Android. Android is built for this. But if you look at the problem in detail, if you want to handle them properly in your application, you need to understand these state graphs very well. And when these two are interleaved, it becomes very confusing. So we have created Lifecycles component to get rid of these problems. And it seems to be working because many developers give us testimonials where a group of problems just disappeared from their applications when they started using these libraries. Another important change for Lifecycles was 1 year ago, we have introduced them as an optional library. But now, they are a fundamental part of Android development. You don't need to do any additional libraries to start using them. Now, both app compat activity and the fragment class implement Lifecycle Owner out of the box. Another interesting thing that happened was the community adoption. So we ourselves create new APIs that works with Lifecycles, but we do other people doing the same in their libraries. And this is so much easier because already AppCompat has these dependencies, so you can easily depend on them in your libraries. One great example of this is the auto-dispose library from Uber. So if you're using RxJava, but you want the automatic lifecycle management, you can just add this auto-dispose command to your stream, give it a lifecycle, and it will manage the subscription for you for free. Now, working on these things, we have also discovered more problems we have. One of them is the fragments view lifecycle. Now, fragments has a very complicated lifecycle. Let's look at an example. So if you have a fragment that when it's created is observing live data, it goes through the regular creation, we create a view for it, and it goes to the resume state. At this point, if you have new values in your live data, your UI will start displaying them. Everything works fine. Later on, user hits a button, so you want to detach this fragment because they're going to another fragment. And we're going to stop that fragment. But once the fragment is stopped, we don't need to view for it. We would like to reclaim those resources. So we destroy the view. Later on, user hits the back button. You go back to the previous fragment. We reattach it. Now, because we have destroyed the view, we need to create a new one. We go ahead and do it, but it's a brand new view. It goes through the regular creation cycle. And now we have a bug. This new view will never resume the state of that live data because you are using the fragments lifecycle to observe it, so we don't have any reason to redispatch the same value. Of course, if live data receives a new value, the UI will be updated, but it's kind of too late because on recreate, your UI has a bad state. Now, this left you with two options. You would either subscribe in on create. It looks very clean, one-time setup, but it will fail if you recreate the view, so you needed to manually update the view. Or you would subscribe in on create view, which handles the creation, but now you have double subscriptions that you need to remove. You lose the automatic lifecycle management. So the problem here is that fragments have not one, but two lifecycles. And we have decided to embrace it and give the fragment view its own lifecycle. So now, starting in support library 28 or Android X fragments 1.0, while observing a live data, you can specify the view lifecycle. And so while you're observing, if it is about the view, you use the view lifecycle. Otherwise, you use the fragment lifecycle, and we manage the subscription for you for free. OK, data binding. So when we started to look at our offerings as part of Jetpack, we have decided to move data binding as part of architecture components. But if you're not already using data binding is our solution for boilerplate-free UIs. So if you have an object like this in your application, in your binding layouts, you can reference the fields in your object, and we take care of updating the UI for you. In data binding 3.1, we have added native support for live data. So if you have a view model like this, which has a live data of a user, and if you pass it as a parameter to your binding, you can use that live data as if it's a regular field in your binding expressions. Data binding will understand that it's live data and generate the correct code. Unfortunately, this is not enough for it to observe it because data binding doesn't have a life cycle. To fix that, when you get your binding instance, you just tell it which life cycle it should use. It will start observing the live data, keep itself up to date. You don't need to write any code for this. We have also rewritten parts of the data binding compiler to be a lot more incremental. So if you have a project with multiple modules, it's going to compile a lot faster. We're also working on making the compilation even more incremental, but they're not finished yet. This new compiler also gave us the ability to support instant apps. Now you can use data binding in the feature modules of your instant apps. OK, Room, my favorite architecture component. So Room is our solution for object mapping that binds the gap between the SQLite and your Java or Kotlin code. One important change we did in Room 1.1 was the support for better multi-threading. So if you are using Room 1.0, and if you have one thread that's trying to insert a lot of data into a database, and you have another thread that's trying to read data, while the write is executing, your read will be blocked, and it can only execute after the write is complete. In Room 1.1 with the write-ahead logging, they can run in parallel now. And another nice feature of this thing, your writes run a lot faster than before. Best part of this change, you don't need to do anything to take advantage of this. If the device is running Jelly Bean or newer, and it's not a low memory device, we are going to enable write-ahead logging for free. OK. Another important addition to Room was the support for row query. But to better understand why we needed row query, let's talk about the query annotation. Now, when you are using Room, you can specify your SQL query in this annotation. You can use the named bind parameters. You can pass those parameters as regular function arguments, and you can tell Room what to return. The best part of this setup is that Room is going to validate all of this at compile time. So if there's a mistake in your query, if your parameters doesn't match, or what you try to return doesn't make sense, it's going to fail the compilation and let you know what is wrong. Now, this is all cool, except what if you don't know the query at compile time? What if you're writing a real estate application where user can search the houses with the price, maybe they want to specify number of bedrooms, bathrooms, whether it has a yard. If you needed the query method for each variation of this, that will be impossible to maintain. So what you do in this case is you create the query at runtime based on the options user provided, and you prepare the arguments for that query. Then you obtain an instance of the Room database and use this query method to get the result. So far, so good. The problem with this approach is that it returns you a cursor. Who wants a cursor? You're trying to get the list of houses. So this looks like a failure of the library. Hence, we have decided to introduce row query annotation. It looks very similar to query, except instead of specifying the query in the annotation, you pass it as a parameter to the function. And then you tell us what you want us to return. Now, here, Room cannot validate that query anymore. So it's kind of you promise us to send the right query, and we'll take care of it. Once you have that, if you go back to our previous example, we can get an instance of our DAO. Now we need to merge our parameters and the query in this simple SQLite query class, which is basic data holder. And then you can pass it to the DAO and get the list of houses. No more cursor, no more boilerplate code. OK, paging. So paging is our solution for lazy loading in recycle view. But to better understand why we developed this component, I want to go through an example. So you have a list like this. It's very common. Every single application has this. User can scroll. But you know, it actually represents a much larger list than what's on the screen. And if you're an application like Twitter, for instance, it's a very, very long list. So you probably cannot fit it in memory, and it's also very inefficient to load all of it. So what you would do is you would keep some of it in memory, the rest of it in database, and you also have your server component where you pull this data from. Now, this is actually very hard to implement properly. That's why we have created the paging library to make these common flows very easy and efficient to implement. Paging library comes with a page list class, which is an actual Java list implementation, but it works with a data source. Every time you access the items in the page list, it pulls data from the data source lazily. So if user scrolls, you need more data, it just brings them more data. Now let's look at how we can get an instance of these classes. It's actually super easy if you are using Room. So Room already knows how to create a data source. It's a great example of how these architecture components work very well together. So you can just tell Room to return you a data source or a data source factory. In this case, I'm using a data source factory because database is something that changes, and each data source represents a snapshot. So we need a factory so that we can create new data sources when database changes. Once you have that, you can use this live page builder class, pass the page size, and call build on it. It's going to give you a live data of page list of users. This is almost the same thing as live data of list of users. Now, in your activity or fragment, you would use this page list adapter, which is a recycle view adapter that works with page list. you would observe the live data every time you have a new page list, give it to the adapter. And then inside your adapter, you can just call this getItem function to obtain the user object. This is a super simple code to write, and we take care of all the hard work of paging it lazily for you. Now, even though I have shown all those examples with live data, paging supports RxJava out of the box. So if you are using RxJava and you want an observable of page lists, you can just get the same factory that Room generates, but instead use the Rx pagelist builder to build your observable or flowable. Now, paging supports paging from the database, as I have shown here, but it also supports paging from the network, or you can combine both database and the network for the best user experience. To learn more about it, please join me and Chris Craig tomorrow at 2:30 in the paging session. All right, now about foo.
I think possibly some of the suspense about what foo is gone now, but yeah, when you think about sort of core problems that almost every app has to deal with, in-app navigation has to be close to the top of the list there. Right now, the framework doesn't really offer anything for you to do, anything for you to use there other than start activity, which for various reasons is not the best option. So that means that for navigation, there are a bunch of things that you have to figure out on your own. And that ranges from executing a fragment transaction without throwing an exception, hopefully, passing arguments from place to place, possibly even with type safety, if you can figure that out. Testing that navigation is working and that the right things are happening when you navigate from place to place. Making sure that the up and back buttons work correctly and take the user where they're supposed to go. Mapping deep links to destinations in your app and having that work. And by the time you've solved all of these problems, you've typically gone one of two directions. You've either written 60% of a navigation framework just for your app, or you've got a lot of error-prone boilerplate. So everywhere navigation needs to happen, you've got a bunch of parallel lines of code that need to be changed anytime the navigational structure of the app changes. And this is all pretty brittle and can end up being a headache. And individually, these problems are pretty tractable, but when you compose them into a real-world example, so say that I have an item screen in my app, maybe a product screen, and that screen is accessible via deep link. But actually, there are other pages that, if the user had navigated here by opening the app from the home screen, they would have come via the home screen, the category screen, and I want the up button to take them through those screens rather than exiting the app, right? So that means that if someone deep links into the app, I need to synthesize these screens and add them to the backstack, but only on a deep link. And talking to a third-party developer, he said, it's when you're in the middle of writing code to do this, on any deep link into my app and synthesize the backstack correctly, you start to feel like maybe this is a failure of the framework. And so that's why we're really happy to be launching navigation, which is both a runtime component that performs navigation for you and a visual tool that works with XML to define the navigational structure of your app and then allows you to just navigate at runtime with a single navigate call. And so the kinds of things that you're going to get for free, right, that you simply need to define in XML and then the navigation framework will handle at runtime for you, are animations, passing arguments in a type-safe way from place to place, making sure that up and back work correctly, and mapping deep links to various screens in your app. And last but not least, no more fragment transactions ever. So I'll show you a couple demos of this in action. The first one is just to kind of give you an idea of what this all is. So we're looking at a set of fragment destinations in my app, and I'm adding a new one, and now I'm creating an action. And this action is the thing that I'm actually going to call at runtime to go from place to place. And you can see that there are a bunch of other options that we'll get into more in the navigation talk. But the one thing I do want to show you in more detail right now is the example we went through before. So this is a simplified version of that where there isn't a category screen, we just have the home screen and then the items screen. But I'm going to, right now, configure this to both have a deep link pointing at the item screen and make sure that if someone deep links into the app, that they go to the home screen first when they hit up or back, rather than just exiting the app right away. So first, I'm just going to configure a deep link on this screen. And the curly brackets that I'm going to put around item ID indicate that I want to extract a variable there and pass it as an argument into the item screen. OK, and now that's ready to go. And if I compile and run my app, that'll just work and navigate to the right destination. Now I just set the home screen to the start destination. That means that it's the hierarchical parent of all the other screens in the graph. So when someone deep links into the item screen and then hits up, they're going to go directly to that home screen. So now I've just solved in 30 seconds what would have been a really terrible and time-consuming task in Java or Kotlin back in the old world. So now I'm going to pass it off to Yeet to talk about WorkManager.
I've been using navigation a couple of weeks for some demos. It feels like magic. So I hope you all liked it. Our next architecture component is WorkManager. Now, WorkManager is our solution for deferrable guaranteed execution. What do I mean by this? You have a lot of actions on Android that you really, really want to do if user does something. For instance, if user tries to send a tweet, you want to send it now, but if there is no network connection, you want to send it as soon as device is connected to the internet. There's things like uploading logs you may want to do if the device is charging, or you may want to periodically sync your data with your backend. Now we know this is not a new problem on Android, and we had some solutions for this. We have introduced Job Scheduler in Lollipop, and we have Firebase Job Dispatcher that backports this functionality in the devices which has Google Play services, and we also have Alarm Manager for exact timing. Now each of these has different behaviors and different APIs. It becomes very hard to implement. Hence, we have built WorkManager that sits on top of them and provides a much cleaner API with new functionalities. WorkManager has two simple concepts. You have the workers that execute these actions, and you have the work requests which trigger these workers. Now, if you want to look at a sample worker, this is basically all you do. You extend the worker class, you implement one function that says do the work, and that function just needs to return us what happened as a result of that work. So you can do whatever you do, and you return the result. There's no services, no intents, no bundles, nothing like that. Once we have the worker, we need to create a work request. So you can use this one-time work builder, or there's a periodic version of this one. You can specify the worker class. But now, you can also add constraints. You can tell it to only run if there's network connection, if the device is charging, or you can specify a backup criteria. So if the worker is failing, how should we retry it? And you can also pass input parameters to these workers. Once you build that work request, you can get an instance of WorkManager and enqueue it. Then WorkManager will take care of executing it. One of the important distinctive features of WorkManager is that it has input and output semantics. So your workers can receive input, but they can also output some data. You can observe this data through WorkManager, but it's actually very useful to chain your workers. So imagine you have an application where a user picks an image from their device, then you want to run some image processing on that picture, and then once it's done, you want to upload it to your server. Now, these are two different units of work. Like, you can process the image, maybe you want to do it when the device is idle, or you can do it anytime, but to upload it to server, you need internet connection. But you don't want to wait the processing for the internet connection because it doesn't need it. This is super easy to implement in WorkManager. So we'll have two different workers. They'll have single functionality. One of them does the image processing. The other one does the upload to server. We'll create a helper function that receives an image file and creates the process image work request. So it prepares the input, just uses the same builder to produce the request. And now we get that. Now we wanted our network upload to wait for the internet connection. So we set a constraint. We say, OK, wait for internet connection before trying to run this work request. And then create the upload image work using that constraint. Once we have them, you can tell WorkManager, OK, begin with the process image work. Once you are done, then run the upload to server work. And then you enqueue both of these as an atomic operation to the WorkManager. Then your device can restart. Anything can happen in between. We will take care of running the two. You can also use this API extensively. Like you can run image processing in parallel the same way. So if user pick multiple photos, you want to process all of them, but upload it to server once all of them are done, you can easily do that with WorkManager. We'll just use the same function. We'll create 3 work requests for each of the images user picked. We create the upload work image the same way we did before. And then we say, OK, begin with all these 3 work items. Once all of them are done, then run the upload work. And then you enqueue that as an atomic operation. And it takes care of running it. Another important feature of WorkManager is that it is not just a wrapper for job scheduler or Firebase job dispatcher. It's actually an executor itself. So let's look at why opportunistic execution is important. So if you're an application where user can send an email, so user hits the send button, you send the job info to the job scheduler or to the Firebase job dispatcher, and it will eventually call you to execute it back. The problem here is that you don't know how long it will take. Even if your device currently has network connection, it may take a couple of minutes for job scheduler to call you back, and you have no control over it. You just don't know. And it results in a bad user experience. To work around that, what you usually do is you also have your own thread pool. Whenever user hits send, you try to run the same thing there as well, and you take care of deduplicating when the job scheduler calls you back. If you are using WorkManager, you don't need to think about it. Because when you send a work request to the WorkManager, it puts it into its own database. Then it tells job scheduler or whichever scheduler it has on the device, OK, I need to be invoked when these constraints are met. But it also checks those constraints itself. And if they're already ready, it will instantly start executing the job. And later on, if job scheduler comes and asks it to execute, now WorkManager knows whether it is executed or not and handles the request properly. To learn more about WorkManager, please join us today at 5:30 in the WorkManager session. All right, what's next?
OK, so I think it's been a pretty great year in Android app development. Hopefully you agree. We launched a set of great new components last year, and we kept working on those and iterating on those. We've launched 3 new major components, WorkManager, Navigation, and Paging since then. So does that mean we're done? Obviously not. We have a lot more to do. And the first thing that we want to do is we want to make architecture components the default way that people build Android apps. And that doesn't mean that it's going to be required, but it does mean that we want to make sure that as many people as possible get architecture components regardless of how they get into Android development. So that means that not only are we going to be building more tools like the navigation editor into Android Studio that are sort of architecture components aware, but we'll also be adding more templates that include things like view models so that people starting a new project have the easiest possible kind of on-ramp into Android development. And in terms of libraries, not only are we going to be building more architecture components, and not only are we going to be building in more of the kind of core architecture components goodness like lifecycle awareness into Jetpack, but we want to look at other Google APIs as well and see how we can make those sort of architecture components aware. so that, for example, if you're calling another Google API that's asynchronous, right, it already has that built in, so that you're kind of getting architecture components benefits whether you know you're using it or not. And then finally, we've heard from everybody that you want us to speak with a single voice. You want us to give clear and consistent guidance. So that means that in terms of education, and that means not just documentation, but it also means sample apps, code labs, that all this stuff is going to be refactored to kind of be built on top of architecture components. So that whether you start with the guide to app architecture, or you just download a sample media player app and just start customizing it, that you kind of, regardless of what your on-ramp in Android development is, that we get you to the best possible place. We know that we still have some areas left to address in the core, and you can see some of those here. So this is just to say that we are definitely not going to stop investing in the original set of architecture components. And there's some, not just problem solving here, but some exciting stuff that we can do around how can we make architecture components as idiomatic and fun to use as possible for people using Kotlin. So there's a lot to be done still in sort of, I think, the core set of app architecture and lifecycle problem areas. So we'll keep working there. But beyond that, I think you'll see something interesting about our trajectory if we look at all the components we've launched to date. So last year, kind of this set of architecture components was, these are relatively small pieces, relatively small APIs that are designed to be used in a lot of different places in your app. And then if you look at Room, Navigation and WorkManager, these are much larger and richer APIs, but they're still relatively sort of self-contained, right? They solve a single problem and they do it really well. Paging also solves a single problem and solves it well, but in this case, we took a very specific use case, right? So lazy loading for recycler view. And we're actually, in this case, orchestrating multiple architecture components and pieces of Jetpack to solve that problem. So paging is a little bit higher level. It's not just sort of, here's your object mapping layer, right? It actually takes a very specific, I know I have a recycler view with more data that I can fit in memory, and uses multiple pieces of architecture components to make that as easy as possible. And we want to continue to build more stuff like that. So we're not just going to keep investing in the core areas of app architecture and lifecycle, but we want to start solving higher level problems and make more and more as easy as possible. But I can't leave today without thanking everybody that helped us get here. The reason that we were able to have a really high quality bar for architecture components was because a lot of people, many of whom are here today, were really generous with their time. And that includes not just filing issues on the issue tracker, but also testing pre-release components, having one-on-one conversations with us to tell us what your biggest problem areas with Android app development were. This has been critical to us in making sure that we're kind of focusing on the right problems and delivering solutions that are going to work for you. So I really have to thank everybody in the community that's been so helpful.
Thank you.
Yeah.